Let's have a look at the convex mirror, which I've said is going to be similar in its properties to the diverging lens in it, that it produces a virtual image. So I think to remember about this one though, see the focal point's behind here? So the focal point length is negative in the formula. That's my symbol for negative. Hopefully you've picked that up. So let's use our usual rays for doing this one. A ray that goes parallel from the tip of the object, and then it's going to appear, it doesn't go behind the mirror, does it? So it's going to appear to have come from the focal point. This whole convex mirror acts like a diverging situation. And so again, you're going to think that it's come from the focal point, right? So I think you can already get an idea what's happening. Whereas one that appears to be going to the focal point on the other side, like that, it would have got to the focal point if it could, is going to reflect again as if it's going parallel. Well, it is going parallel. But in this case, we can then think of an observer over this side looking at the situation, and they're going to see these rays as if they did come from behind the mirror, but they're not really there, so we call them virtual. You can see they do intersect behind the mirror. They don't intersect on this side, so they can't produce a real image, but they do intersect behind the mirror. So we end up with an image there. Now, it's diminished. So this type of mirror produces virtual, diminished, upright images. Now, going to our formula, our Descartes formula, we need to remember that this is negative and the rest will work out, but we will totally expect our DI to be negative for this situation because it's a virtual image. So I'll make another little video in a sec. Or do I need to make another little video? I don't think I do, because I can just go straight to looking at the diverging lens. I'll just use this little one here. A diverging lens is one like this. Alright, and let's see how that is similar, if we find it to be similar, to the convex mirror which we just looked at. So this is a diverging lens, and again we said that we want I'll put the focal point there, focal point there. Diverging lens, we want the focal length, or the focal length is negative in our formula. So let's put an object here and see what we get. Put our object here. Do a 2 centimeter object, that's good. And again, you've got to ask yourself, which way are you looking at this object? And I think you'll see which way you're looking at this object. But let's just do our rays first up. We said that a ray going from the object parallel is going to appear to have come from the focal point. It's going to diverge. So that's parallel, but it's not going to go through this one, because this type of lens doesn't do that. This type of lens makes rays diverge. So it's actually going to look like it came from that focal point. Makes sense with that type of lens, doesn't it? A ray that came through that, well, what we're actually going to do, I'm going to use a ray that goes through the center. We said we can always make a ray just go through the center. So if I do that, we can do that, right? So already we're going, okay, maybe this is going to give us something. Well, it is actually, because this ray is going to look like it came from here. All right, and so we're actually going to end up with a little DO in there, or a little image in there. So that's the virtual image being produced. Where's the observer going to see it? Well, they would see it over here. They've got to be on this side to see it. And they're going to see a virtual, upright, and diminished image. Sounds similar to what we just got with the convex mirror? Yes. When we do our formula, what we end up with is the same situation. F must be negative. We're going to end up with a di, which is also negative. Distance to the object, as usual, is just the distance to the object. Distance to the image is the usual distance to the image. So this is the one that does that. It's again, what you find with these guys is they can be a little tricky to figure out the lines when you do them. The 2012 level 2, you definitely have to do these diagrams, so it's worth looking over the videos and memorizing what goes on. I think we've done all the situations now. So when you have a look through these, always remember the three rays. The three rays, you can go parallel. It's then going to go out through there. You can have a ray that appears to come from the focal point and will then go parallel, but you've got to always be thinking, okay, what's that going to give me? So these two rays on this one are the ones that often you might find two rays work better, and in this situation the ray that goes parallel and up there and the ray that just goes through the center will give you a nice intersection point for the image. Alright,